Hello and welcome. My name is Mark Horseman, and I'm a data evangelist with DataVersity. We would like to thank you for joining today's DataVersity webinar, Data Modeling Mastery, Structuring Data for AI and Analytics. It is the latest installment in the monthly series, Data Ed Online, with Dr. Peter Aiken. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. For questions, we will be collecting them by the Q&A section. If you would like to chat with us or chat with each other, we certainly encourage you to do so. Just to note, the Zoom chat defaults to send to just the panelists, but you may absolutely switch that to network with everyone. To open the Q&A or the chat panel, you'll find the icons for those features in the bottom middle of your screen. To answer the most commonly asked question, as always, we will send a follow-up email to all registrants within a couple of business days containing links to the slides. And yes, we are recording, and we'll send a link to the recording of this session as well as any additional information requested throughout the webinar. Now, let me introduce to you our friend and my friend and our speaker, Dr. Peter Aiken. Uh, Peter Aiken is an acknowledged data management authority, an associate professor
Hello
at.
and welcome. My name is
Oh,
Sharon.
Sorry about that.
well, that audio's working.
You're back on, Mark.
It's like, how did that happen? um, Peter is the president of Data International and associate director of the MIT International Society of Chief Data Officers. For more than 40 years, Peter has learned from working with hundreds of data management practices in more than 30 countries. Among his 13 books are the first on making the case for data leadership, the first on focusing on data monetization and modern strategic data thinking, the first to objectively specify what it means to be data literate. International recognition has resulted from these, and a pre-COVID intensive worldwide event schedule. Yeah, we're back into reality, pre-COVID reality again, Peter. We're on the speaking tour now. Peter
I went to
also
China for
hosts.
the weekend in the fall.
Well, there you go. Yeah. Peter also hosts the longest running data management webinar series on dataversity.net. This webinar right here, before Google,
Yeah.
before data was big, and before data science, Peter founded several organizations that have helped more than 200 businesses leverage data. Specific savings have been measured at more than $1.5 billion. His latest venture is Anything Awesome. And with that, I will pass it over to Peter to get things running. Hello and welcome, Peter. We had a little bit of a rocky and comedic start to today, but hello and welcome, my friend.
Absolutely. It's good to see you, my friend, as well. Again, apologies for stomping all over you with your predecessor there, but at least at this point, we can rock it off to fumble fingering on the whole thing. So the idea here is that if you're not modeling your data, you're really not understanding it well enough to do analytics, to do AI, or really to do anything else. So we're going to jump right straight in with why model anything. What is data modeling in particular designed to accomplish? Why and how should I look to AI for help? And then we'll look at three specific types of modeling, which are conceptual, logical, and physical data modeling. Tie it all together, which will be sort of integrative understanding of hopefully all of these things that you're looking at on this. So let's dive right in. And again, why model anything? Well, this is one of the most important takeaways from this. I was preparing a lecture for my class talking about the data lessons that you can gain out of The Big Short. I'm not going to relay them to you here, but it came up with this really interesting piece because I had also been working obviously with some of this type of content in here as well. And it said, interestingly, The Big Short is the ultimate cautionary tale about what happens when a logical model ignores the physical reality. And so it was a kind of interesting perspective on this. And I have had several times where AI has suggested things to me. For example, I was doing something and it would come back and say, this would actually make a really interesting chapter on this book that I know you're writing. And so, from that integrative spot, bear with me, and I think you'll see a lot of things in here that are very useful to you as you try to improve the ability that you have in your organization to do data modeling. So we'll start out with the usual apology for, yes, most of the data has not been around for very long and it's becoming increasingly more available, and we have just increasing amounts, and the supply and demand curves are very much in favor of the job applicants at this point, which is to say that the data is far surpassing our ability to keep up with our analysis capabilities, at least given the current sort of approach. And that this means that data debt, as it were, is still slowing progress, decreasing quality, increasing costs, and presenting greater risks, knowing that 80% of your organizational data is redundant, obsolete, or trivial should change how you approach the overall process. Let's talk about how that process involves modeling. In particular, if you were building a house, would you build a house without an architectural sketch? No, the model is that sketch. Would you have an estimate? Yes, it gives you a very good idea of how demanding the work is going to be. If you hired constructors instead of constructors all over the world, they're contractors, it should be. Anyway, model is the common language for the project team, and you'll find that happen. It happens. Would you like to verify the proposals, and you can test it on paper before you can spend thousands of hours of implementation work? Would you like to repeat the process? And by golly, would you just drill into the walls of your room without knowing whether the drill would encounter an electrical or an HVAC or something else that would be problematic in that sense? Models are used, therefore, to store and organize information, to filter out extraneous details by you as the modeler deciding what is essential to be in there. And it defines this set of information that helps us to understand complex system behaviors. And I'm showing on the right the Easter Island statues, and they've had a number of different ways of trying to figure out what they did. And many of them involve models. So I'm showing a couple here, but it allows you to evaluate the scenarios without being out having to do this. And what you're seeing here is that one group said we could move these ginormous statues from place A to place B by rocking them back and forth. And then they proceeded to recreate something like this and then rock it back and forth. And this just means that models, we use them more often than we think about. They are equations, they're simulations. They can be physical models, they can be mental models. The way in which you approach an ethics problem might be part of it. And models are hugely important in the sense that we always appreciated Ellen's virtualization of this. I want to make sure she gets full credit, but it's a lot of different things that you can use it for. And it's not that you have to use it for all of them all the time, but that models end up being this part of your toolkit that you use to figure out how these things work. Again, lots of things that we talk about in a large sense of just being really, but we really talk about translational skills. They used to be called soft skills in here. But again, just learning to read the room is a critical modeling skill as far as that goes on this. So definitely want to be modeling to do that. But what is data modeling in particular designed to approach? And my easy answer that people seem to like a lot is that it needs to connect the vocabulary that the business personnel use to correspond with the technical personnel. As a U.S. government employee at one point in time in my career, which was in the 1990s, so give you some time back on that. I was sent to the wrong city because somebody transposed some metadata on a form, and I went to XYZ instead of YXZ or something like that. And it's just so amazing that it happens, and yet this happens. It's one of the biggest barriers to progress being made from a technical perspective. And of course, then we have the actual system itself, because if all three of these aren't connected well, it's not at all easy to make changes, to modify, and to build on top of as well. This same kind of relationship occurs between architecture and engineering. And what you'll see here is that the engineering folks are the technical implementers of the broad concepts that the architecture proposes, and that those craftspeople then deliver specific pieces, and there's obviously a symbiotic relationship between the two. Similarly, models and architecture have a similar kind of symbiosis. Sorry to be so alliterative here, but again, they are going to be a part of all of this. And we'll take it just one step further, which is to say data models and data architectures are really what we're describing in this particular context. So let's dive into a specific example of how model can help understand things. And I found this has been very useful over the years. Many of you understand the number 42 to mean something. If you happen to have read The Hitchhiker's Guide to the Galaxy, it might be the meaning of life, the universe, and everything. If you are a Jackie Robinson's fan, it might be his jersey number and the wonder of his the title of his wonderful biography. And then a third one is whether Peter is allowed to drink adult beverages in the Commonwealth of Virginia on this. And so these are different ways the number 42 can be used. In that 42, in that case, would be added to 25 to determine whether or not I was in fact eligible to drink. And of course, you guys can figure that out for yourselves pretty well. Well, what it has done is associated a number of different facts: the Hitchhiker's Guide to the Galaxy's meaning of life, Jackie Robinson's jersey number, or whether I'm allowed to drink alcohol in the Commonwealth of Virginia, with a different meaning. And that is the essence of data. It's a fact combining one or more meanings. We want to make sure we understand which ones are which, because if we get them mixed up, it can be incredibly problematic. We also want to draw a distinction between data and useful data, and that is another value that you all as data modelers will have to be able to bring to this overall equation in here. We go to the next level up, which is information, and that is we take useful data and combine it with a request. If a data hasn't been requested, it's very hard to make it real case for it that it's really useful in that sense. Obviously, here you can have data without information, but you cannot have information without data. It goes almost without saying, but sometimes we do need to say it. Finally, getting up to this large top level, it's been used knowledge and wisdom and interchangeably with intelligence over the years, but all the way around. And you can see there are 6 business rules down below that formally arranging this model into an architecture, now you have an ability to explain quickly and easily to anybody the difference between these and why they perhaps should or shouldn't be managed together or not. Again, the details are organized into larger components, and this is intricate work that has to be done extremely carefully. Larger components are then organized into models, and that introduces dependencies in the process, and then the models are organized into an architecture that is organized for purposefulness. Do not ever let anybody produce an architecture model for you without describing to you, is it at least faster, better, cheaper, or less risky than the current or whatever current set of requirements are. Data structures are expressed this way as architectures. The attributes are the intricacies. The entities and objects are organized into models, giving us the ability to formally define dependencies in here, and then our purposefulness on the end of it. The key with the purposefulness part is that most people don't really understand why I should have a big data model like this. And the goal is, of course, not to have the data model, but in fact to understand what you have. And if this is in fact what you have, then it's significantly perhaps challenging to try and figure out the puzzles. See, each organization has lots of data structures, but ideally you should try to go for as few data structures as possible in your organization. And the actual elimination of data structures is a goal that data management can, in fact, and be measured upon. In order to do it, and many organizations have gotten quite successful. Again, if we just look at the n-tiered algorithm problem here, I've got n times n minus 1 divided by 2 number of interfaces if I want to make the upward theoretical worst possible configuration, and I can use that formula because it applies linearly. Well, just to give you all a comparison against that, the Royal Bank of Canada actually gave me permission to use their numbers many years ago. They had 200 applications and almost 5,000 batch interfaces between them on there. So let's just look and see, first of all, is the Bank of Canada in a good shape or not? And if we plot them out right here at 5,000 interfaces in there, they are clearly below average, but still they have to manage 5,000 interfaces. Data modeling is iterative. Once you find out what's going on, they're developed in response to specific organizational needs. And many people think, I don't need to do this anymore. However, there's 2 reasons why you should. And the first one has to do with the cloud. If you're modeling in the cloud, you need to be considering other things that you were told at one point in time that perhaps are not true in the cloud and can cost you lots of money unnecessarily in order to do this. The second part of it, though, is that also I'm often buying packaged software, commercial off-the-shelf software and things like that. And while that is a consideration, if you have the option and are far enough along your your procurement process, it's really important to get a logical model of the system so that you can determine that if you purchase that system or the services of that system, it will either complement or impede the existing data flows within your organization. And failure to do that is not considered best practices these days. On here, data is sand in the machinery. And the more you're doing sand interchange and things like that, the less well your gears are going to function in order to do that. A lot of it is related to the princess on the P by Hans Christian Andersen. You can see the PM circling down here at the bottom, and it is making the princess up top here very sleepless because the P is in the wrong place, and it's therefore making her uncomfortable all the
Peter,
way through. Well,
Peter,
yes.
we're getting a couple of requests in chat just to slow down a hair. Everybody's trying so hard to keep up.
I'm trying so hard to get through the material for everybody. It is
Yeah, you've
recorded,
got so
folks.
many good slides. Yeah, it is
I will take
recorded.
a breath. Thanks. So again, the princess is sleepless, and that is unfortunately the way it works too. A data error in the baseline architecture of your program is going to cause that same program to be locked in for life. There are websites you can go out there now and look up the errors in the Oracle database and things like that. Again, it restricts the ability to get benefits out of it, and truly 20 to 40% of your IT budget is spent currently migrating, converting, or improving data around that. So again, the longer costs more, delivers less, cheaper. Got to have one of those, but you can't do all of them at once. And a really good way to articulate this, I learned this last year. I was very fortunate to work with a group called the Manufacturing Leadership Council, and they introduced me to a concept of 110, 100 rules for data quality. It's quality to them in general. So if you approach them with this idea of 110 and 100, they will understand. And the idea is very simple. Of course, if I fix the problem at the source, it costs me $1 to fix it. But if I wait until it gets to the warehouse, I'm employing data engineers, and they're using complex scripting and things to fix something that I should have fixed at the source. And if it gets to the business, I have a rather larger risk that shows up. So again, validation rules, warehouse, and the business within there. The 110, 100 rule is something you can take with you to the bank, because your management does, in fact, understand that, particularly if you're in the manufacturing sector. So, how and why should I go to look for AI for help? And I'm a Gemini proponent, not particularly anything other than I happen to be doing a lot with YouTube videos. So this is very convenient here. But it has a facility called Gems, and Gem, you can create a persona. And what I did here on the screen, you can see I said, respond as a seasoned data modeling professional. You're excellent at illustrating how data modeling used to solve this, et cetera, et cetera. You can create your own persona. You can ask it what prompt you should use to get the results that you want. And it does a great job of it, because now that you have this ability, I simply ask the question you can see up here at the top: where can I find a candidate data model for the pharmacy? Which is a pretty vague question. And it came up and gave me what I consider to be very good answers, very good quality answers. Again, you have this still issue of hallucination, but in this instance, it did not. Let me take you to a more direct use of AI within the data modeling environment. Here's a data model that might have been created by a student who unknowingly didn't realize this wasn't an optimal data model. So you might take this data model. It's, in this case, if you were making a MP3 player for your computer back in the days when people used to do that sort of thing. Well, I said, again, you can see in gray, a database consists of the following rows: ID, purchaser, song, price. Is the table normalized? And of course, it gives you a little praise for thinking about normalization. But more importantly, it does give you, in fact, good information about it. And it says, probably you can create a better structure. On there, it's just the last line on the page right there. Again, going into this kind of here, benefits of normalization, what types of things are happening, how will third normal form benefit, et cetera, et cetera. Again, good information. There's actually I came off of a meeting a little while ago where somebody had said that perhaps the AIs had ingested our DIMBOK, and that's great. If they did, they at least seem to have gotten it correct. What do you need in order to get AI to work? And I think this is a question that the world is dealing with right at the moment. I believe that the answer is, at a minimum, you need a context model that is robust and balanced correctly, and that you need to feed the process model and the data model or architectures outside of it in order to do this, because only with those two artifacts can you then create a CRUD matrix. Those of you that are encountering CRUD for the first time, I apologize. I work for the education establishment, and for somehow we've let you down, but CRUD stands for create, read, update, and delete, and it is an invaluable tool, but more importantly, it's a milestone that shows that you have achieved a sufficient understanding of how all this works out within your organization in order to do this. CRUD matrix can tell you what entities can be used, what can be viewed, what fields can be modified, what entities can be deleted, what information. It's governance right at the heart of the pact, and the AI understands this governance in a very, very nice way that you can make use of. So if you ask it a question, feed it information about it, it will come up with candidate CRUD and RACI matrices as you're going through all of this. So we're going to talk now about the modeling types. And again, the thing that you've seen flashing at you, the whole campaign for this is built around the idea that all data modeling falls into these categories. You have your as is models, you have your to be models. Those models can be not validated or validated. You would prefer to use validated models, I presume. In fact, I consider the not validated models to be riskier on this, and that those models can be further subdivided into conceptual, logical, and physical models. And this is the universe. In all data modeling, you're going to be doing some sort of a transformation on this type of a framework. There are all kinds of tools that you can get into to use. We don't have the ability to do that right now, but we are running some very interesting experiments to see how far AI can take us in that general direction of supplementing our previously used knowledge of metadata around this. Forward engineering, very straightforward. This is what we teach in schools, and it's the idea we start off with the requirements that are what we have to do, and then a design, which is how are we going to do what we specified needed to be done, and then we actually build the thing. But you see from my little note there below, in the real world, only 20% of your time and effort goes into building new stuff and enhancing existing stuff. Means you should really pay attention to reverse engineering, which is starting to get some knowledge in the textbooks, but no skills around it at all. How to go from a physical as is to a logical as is and a logical as is to a conceptual as is. Again, even has a formal definition: evolve existing systems using a structured technique aimed at recovering rigorous knowledge of the existing system to leverage enhancement efforts. Now we get to re-engineering, which is the idea that most people use the word but don't understand what's happening. It's the idea of, first of all, reverse engineering the existing system, sometimes having to go back and readdress the requirements, sometimes not, and then using that information to inform the design of the new system. If we don't have that formal traceability, we're not doing re-engineering in that sense. And this gets into a couple of other quick areas too. Data migration, unfortunately, big expense for many companies these days as they change from systems. And the way it typically has been done in the past is we do what's called forklifting. We take the data and we map it onto a spreadsheet. Somebody says, here's where it goes. And in sometimes that works, but in the most case, you're missing out on a very significant opportunity here, which is to move from a technology dependent and physical move through the phases here. Again, you can see to as is, and then minimally to as is to be back in to employ the new system. And again, we teach that in the normalization context by saying you have to follow these pathways in order to go forward. All that's very important, but we forget the real rationale, which is when we get to this stage, we're oftentimes adding additional requirements, merging with another database, trimming requirements, changing the strategy behind the entire approach, moving from a non-mobile to a mobile network. All sorts of things can happen here in order to do this, making this activity significantly more valuable than it has been in the past. We can turn the same model on its side and take a look at something called the ANSI Spark architecture for databases here as well. You see the conceptual schema, you see the physical schema, the logical fits in between the two because in practice we found it's extremely important and facilitates communication in there. So again, here's our definitions. You can see them right there. What is happening is that we're trying to create ways so that the user experience is as consistent and improvable as possible, as opposed to having to really significantly disrupt things otherwise potentially. Some of you may remember the Zachin framework. If you're seeing this for the first time, hit other people up in the chat about it. They will point you to resources in here. But the idea, we're going to focus on this piece right here with the how and what columns and look specifically down here at the modeling levels. Again, you can see perfectly fit for conceptual, logical, and physical modeling. Next, I'm going to show you an example of how this is used in the real world, in this case, by a bridge. I, for some reason, like bridge metaphors, but this is something called the Minao Viaduct. It's the highest bridge in the world, still in 2026 here. And the alternative to this bridge was this road that did this kind of thing here and took you a long time in order to do that. So the conceptual model here was this one, and gosh, we have to get oriented first of all. So let's fix that. There we go. And it's at the entity level, typically providing focus and guidance to get started, sometimes thrown away, rarely maintained as far as that. But what should have been part of this is to say a two-lane motorway deck, average 200 meters above the valley. That's very, very tall, saving an average, excuse me, of 1 hour travel time in order to do this. The logical model for this is, so you're going to do this, show me how you're going to do it. How are you going to get across this valley? And you can see here again, the very large towers that are there, each tower generally taller than the Eiffel Tower, which gives you just a set a sense for that. Again, from data modeling, you're going to probably go to the attribute level and maybe sometimes understood at third normal form, depending on the business context. They're developed to be refined because it oftentimes requires tailoring in order to get there. And you can see here again a lot of information that says, yes, I think you know enough about what you're doing to actually solve this problem, which they, of course, then went to. How do we solve the problem? Well, the physical models. Again, you can see the topology below, but these were the blueprints in order to do this. Not just the blueprints, though. Watch the models that they created as part of this. So we're going to look at these towers. They built an interim tower between the permanent tower, which is to the left and to the right of that tower in gray. You can see the interim tower is in red here. And again, the model was that, first of all, we have to move these things sideways without pushing on those towers, because if we push on the towers, they would fall away. Only when we got all the way to the center here and sealed the deal here did we achieve structural integrity with the bridge. And I say we in the royal we of the engineering community and database community, because you all know what structural integrity means in order to do this. So how did they get them to do this? Well, they developed a special lift system here. And you can say, whoops, I'm sorry. I'm going to go back again. Oh, goodness. Went too far. All right, we're going to skip that. But anyway, there's a great video of that one coming off there as well. So let's dive in and take a look at conceptual modeling in detail. Again, the left-hand side of the diagram here is the most critical layer because it defines the what and why before you ever touch the how of the database. The hardest thing I have to teach young people these days is why to do that. But we can start to motivate harmonize vocabulary, figure out what are the issues and trade-offs that we need to make, document specific business requirements, trying to get rid of the word draft as much as we can on these things. All sorts of ways of organizing these models. Most of them, as I said, are done and sort of come back and say, okay, we'll do that later. Now, again, here is a generated piece which you can do, and how a Gen AI model can transform the specific set of business requirements directly into a logical ERD. So you may need to skip the conceptual. The conceptual model is primarily used for communicating. So if you are working by yourself and you don't need to communicate with everybody else, by all means, jump straight in. However, if you are communicating out external from yourself, you're probably going to benefit from that. Again, at least two, right? Good, cheap, fast in here, and oftentimes you can pick only one in order to do this. If you're not doing this, you're not having an architecture discussion. This is the important part. Now, I mentioned strategy as far as that goes, faster, better, cheaper, and less risky. We didn't even use the word until about 1950, when the management consulting part picked up from this and started to have a lot of fun with it in here. They made it into a thing. It really has always been, from the military perspective, who invented this, a process rather than a thing. So a pattern in a stream of decisions is a really useful vocabulary word, definition for the word strategy. A former Walmart business strategy was everyday low price, and that was easy to understand. Wayne Gretzky had a strategy of skating to where the puck will likely be, and then he was more likely to score. Napoleon had a question of how do I defeat an enemy larger than mine? His answer was divide and conquer. By the way, Napoleon's strategy was ultimately unsuccessful, but that's a different story in the long run. Conceptual models are used to support strategy, for example, efficiencies. This has happened to me multiple times in my career when I worked retail. The key was management sorry, and I went by too far on that one. There we go. Management would say all managers need to sell. Sure, we understand it's a bad sales force and things like that, but you've classified us as managers, and so therefore we had to create a separate salesperson structure, and then we got yelled at for having too many employees. Again, you can see here this was actually quite strategic in terms of the misfire that occurred on that, and I get to vision that several times. What are the kind of things here? Well, again, semantic discovery of business speak. You can actually read the 1K forms that you file. Those of you that file 1K forms or your strategic plans and understand this. You can do contextual analysis and see how you can form with universally accepted practices. And there are universal models. Poor Len's thing has gotten sucked up by the AI in there, and still it's useful for us and sad for the IP folks, which we're on both sides of that, of course. Again, you can do prototyping. You can create all sorts of designs very easily and get the glossary to model gap bridged quite easily in here. So that's conceptual modeling. Let's look now at logical modeling. Logical modeling is that middle layer. Gen AI doesn't replace the architect. It acts as a high-level accelerant and peer reviewer. Now, the older I get, the more I like being yelled at. I know that's sort of strange, but I get corrections that are made when I'm yelled at. And if I don't, I'll be just a cranky old man. So anyway, motivation here is to get the size, the shape, and the provenance. What are we really talking about here? I know you want customer data, but you've got to be more specific than that. Yeah, I'm sure you've all heard that one before. But we've got to have those discussions because even though you're an Oracle shop, we're going to talk about perhaps not doing them with Oracle technology. And even if you know what the answer is, you still need to have the discussion free from technology considerations. That you can prove that these data designs satisfy the business executive objectives, and most importantly, generate as much of it as you possibly can. So the as-is logical data models would first thing you do is you go back and challenge the conceptual model and say, will this in fact do what you say there, or has our thinking of it evolved? In which case, sometimes you need to go back and get the conceptual. We're not going to get into that whole cycle there. But some organizations go through it and quite usefully too. Again, what type of relevant external information are we going to need? And for the 2B models, this is where the system data capabilities are going to come from. So while we devote a third of code to interface issues, we also have another third of code that moves the data around in there and facilitates the common vocabulary that we have. And that vocabulary, of course, is the business glossary. Again, you want to start, if you will, of the enterprise taxonomy. It's got initial concepts for what goes in there and engages the business community in order to speak. And I do want to give you a very specific example and an easy way to do it, particularly if you don't have significant technology resources. And this is the story of Nokia, one of the wonderful things I learned about them. By the way, a fantastic book if you get a chance. Really, really interesting. They started out as a company that originally made tires and rubber products, morphed into consumer electronics, mobile phones. And just to know, as they were in the mobile phone stage, they decided they wanted to become a worldwide corporation, which meant getting listed on the New York Stock Exchange. And in addition to that, the vast majority of the Finns are bilingual, but 2% of the population speaks Swedish. So they're trying to make sure that they cover that base. They were all told in Nokia that you had to have all your business meetings in English starting effective a certain day. And they use this wonderful uh, technique of lowering the barrier to learning more about the English language, which is that when a word was used that it was unknown, they would then sit down and say, well, did everybody understand the use of that word? And they'd take a quick vote. And if the majority said no, they would submit the word to go into the cultural process of creating a common vocabulary. They would actually have a form that would pop up on the web, and they would all subscribe to it and send it in. And at the end of the week, Friday or end of the month, depending on what the cycle was, there was usually some alcohol involved too as well. They would look over these new suggested terms and produce the result in a single web page. So checking the Nokia term bank was as easy as searching a web page for clear English definitions. It was so useful. Again, they would go there to check to see if there was a golden definition, vote on inclusion, and review produce new cycles and produce new things. And again, the NTB was this Nokia term bank. Well, obviously that turned into their corporate glossary very, very easily in order to do that, building on existing technology, and most important, the culture of it's bad not to ask questions. It's confronting, but it's bad. They did a really, really good job of this. So the typical thing that we do is that you say, give me a definition. Well, bed, something that you sleep in. Let me show you that a purpose statement is better. The purpose statement in this instance was talking about hospital beds on one of the projects I was on. And it said why the information was being maintained about the concept. So while you're getting definition, go ahead and get the motivation as well. Purpose statements more powerful than simply definitions. And when we found out the information was about beds and rooms, they were going to keep track of hospital beds using an RFID framework. Again, older example, but still very, very useful. Where did it come from? We were able to get this. We were able to look at the attributes and things. But we also found very, very quickly that you would also have to have a room designated as the hall or the elevator. And this, of course, blew the entire place, which, because the hall and the elevator are the two primary places that residents get lost when they're in hospitals. In here, you can see the association, 0 or more beds. Again, changing the status from draft to validated. Very important on this. Let's look at the proper relationship for these entities. And here we'll start out in this instance, beds and rooms. What are the relationships to them? Well, here we have a relation. A bed is related to a room. That's nice. Really, really unhelpful, however, on this. Next is many beds are related to many rooms. Well, it's still pretty unhelpful. If that's really the case, we've got a different problem on our hands. Probably the best way to look at it here is to say many beds may be contained in each room, and each room may contain many beds. You have to read the top and the bottom in this case, or the left and the right if you're doing it. And what if the beds can be moved? Now you have a very interesting challenge here. There are some formalities that go along with this. This is the information engineering method. There are lots of others, but it just means exactly one, one to many, eventually one, zero, one or many, or eventually one or more as optional pieces that come down the pike. Very, very useful from a time differentiation. What's a relationship here? Well, it's a natural definition between two or more, one or more entities. Let's try that on here. What are we talking about? Well, rooms, beds, patients. A bed is placed in one and only room. A room contains 0 or more beds. A bed is occupied by 0 or more patients. A patient occupies 1 or more beds. Again, you can see some of these may not be exactly right. Once you codify them, it becomes part of the system, part of the way in which the system works. Here's another definition here, just a core business model trying to keep track of how things are supported, one to many, many to many, zero to many. You can actually ask this to come up from the AIs here as well. There's a uh, logical data model that is broken up into 5 model views. This was done for a state agency here. You can see the views were taxpayers, governors, vendors, program delivery, and clients on here. So here was the taxpayer view. And again, I'm going to flip through these rather quickly. You'll see that they come out in print. You get the whole set in order to do this, but there's clearly an overlap. We need to make sure that those are speaking the same language between the first view, taxpayer view, and then the second view. The thing is the same as payments, so that's easy enough. The governance view is a little bit more complicated, but nevertheless correctly reflects reality that they're faced with. The program delivery view, again, same data model, different smaller perspectives on it. The vendor view, how does the vendor interact with that particular agency? And we put it all together and come up with a conceptual view. While this is good, most people aren't going to put this on the walls and work from it. What they will do is a subset of it. And so here was a group that was working in insurance, and they were having trouble differentiating between these terms. Well, you can see here the terms are quite clearly defined, and this says this is going to be the way we will do it from this point on. And we solved a lot of questions, made a lot of people quite happy going through the process here in order to do this. The analysis of work products will oftentimes become reference material. Even more important to maintain that do not keep the ones with draft on there. Keep them completely separate in order to do that. Otherwise, it will become more and more problematic for you. So how do you use Gen AI to actually do this? Well, again, this natural language you can take in, it's kind of like vibe coding, but you want to be a little bit more focus than just trying to vibe it off in order to do that. But if you could reduce that blank page by 50%, most people would be pretty happy with that. So it will absolutely read whatever PDFs that you filled into it, and it will do a job that will be worth doing. It won't be perfect, and you'll have to know what you've got that's perfect and not, and how to use that with a process that's going to work for you overall. Second way is trying to figure out what's going on with these universal patterns. And again, I was reminded of one organization that I worked with that purchased one of these universal models and wanted to compare against it, and then started telling me that the universal model was wrong. I was like, oh, it's fine, but we're not going to change that. If you want to get with the universal standards, or you should get on the standards board and, blah, 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 the rest of the whole process. Wonderful superb ability to go in and automate the process of using data as metadata and semantically enriching tagging these things that will come up with suggestions for you that are just wonderful as far as that goes. And finally, the ability to generate synthetic data to validate the model at a very cheap and inexpensive way in order to do this. All sorts of really, really good opportunities here at the logical data modeling level. And that leaves us physical data modeling. Again, furthest over here on this. Again, we've got some to be and as is and not validated and validated. But the question here is, whoops, sorry, I went too far. There we go. The real key here is that we're trying not to use the logical model going from the how to the what. This is where Gen AI really happens in there. I'm just doing a bad job with the slides today. Sorry, guys. And my expectations, this is where the moves to the AI moves from being a scribe to bridging the gap between the modeling in here, and I'll show you how that works out. So again, motivation-wise, right, lots of different diagrams. We don't even tend to teach data flow diagrams in university anymore. It's really sad. They have no idea what a glossary or catalog or the utility of them is, but you do. And so nobody would sit around and craft EDL. The case tools used to put them out, but you can have these systems do it just absolutely superbly. And the key is to change the mindset from I'll just make a modification to this to I'll respecify it. Because the minute you start modifying it, you've created that old legacy thing that's going to be a problem in order to have that. So you need these blueprints in order to go through. And for a physical model, it's the foundational system documentation, the data that is within that context model that I showed a few slides back. It can often be reverse engineered in a semi-automated way, which is super, super useful. Some of the case tools just directly plug into them. Others are out there that do it. I use one called DB Schema that's a great tool. The physical models are the specification. If the models aren't correct, the data is not going to be read correctly, and you're going to end up with problems on your application side of things here as well. And you can understand what data elements are likely to be coming down in the future. And again, generated in most instances in order to do this. Just avoid the understanding here that it is an imprecise understanding. You're dealing with the real things here. There should be a one-to-one correspondence in order to do this. The data modeling requirements are very, very esoteric because they're talking about what are the data things, what do they do, and how do they interact, which is a great place to start. But this is an amorphous piece between a couple fingers there, so I didn't have a good AI to create a good model on it there. But it represents those business requirements. If again, as an example I've used before, what a manager said, no, a project must be owned by a one and only one department, but the database had been programmed so that multiple departments could own a project and circumvented the guidance that was there. It was a real issue for them. Again, it's going to have this essential material, particularly that you're working with your data customers, and it's going to function as that sheet music, just the same way. If you have a musically inclined team, they will understand that 100%. The metadata that's going to be essential to the other functions, definitions for governance, lineage for analytics, et cetera. And again, the process is iterative. It's going to include these different types of models, but the modeling is done to accomplish the goal. And what we're trying to get to are the lists of organizational persons, places, and things. But you say, Peter, that's the master data. Yes, it is. And of course, it should be treated that way. Master data is a admission that whatever you're trying in the past isn't working quite as well, but it'll get there. And again, these things are going to be created, read, updated, deleted, and archived. It's a fairly simple kind of world. These are the attributes of the world that we're trying to work at, the description of the things that we're trying to get in order to do this. So here's a couple of examples again, characteristics of clubs and regions. Well, clearly there's a relationship in there and there's some sort of definition. So we've got every region can have multiple clubs, but each club can only belong to one region. It's going to have some other types of characteristics. The weather might determine the type of club here. The pound sign implies that we're going to determine it with a primary key in there, and there's likely club specific maintained that's in there, and that some concept organization exists above the club level in order to do this. Clearly, each club must be part of a region. You can't have it the other way around. So when we do the modeling in here, we might characterize these these things, and the tables are available, for example, in this instance, with a reason. And so again, these are business requirements that we're putting in here. The characteristics can be shared. All clubs may have a status. There may be few of them. We probably don't want that as a free-form input. Many reasons can be assigned to the reservation, right? Again, lots of different pieces, but each of these does end up being a specific requirement in order to do this. There are variances that involve keys and evolving definitions. Hence, again, this mandatory glossary. We've just got to have it in order to do this. So I'm going to give you a quick quiz here. Here is a data model that we used at one point. I'll even tell you what it was called, the Student Database Master. And of course, it's very unreadable. I do not expect you to read it, but notice the pattern here. We have one parent, lots of children out here. What this means is that these guys invented the star schema way before the folks that claim to have invented it in here. But you get a sense now, if I tell you this much information, you now know that there's a parent and child relationship between each of the lumps that are on the diagram and somebody there that would typically be a student, a master index for all of our students that were here. We were proposed as a replacement for this system. At one point, we asked them to send us the model. As I said, getting that logical data model on procurement is an absolute best practice in here. This is what they sent us. They never could answer specifically what were we trying to present. Was this a process model, a data model, a hierarchical model, a network model? There's a story, catch me on the side, but somebody almost ended up in jail in order to do this. You can see here that the physical model is critically important. It obviously disqualified this particular vendor on this. I wouldn't tell you the story if they weren't true, but it's fantastic on here. So let's look at a couple of these ways of aiding the physical modeling. Again, generating that DDL, it's fairly confined. It's the type of thing where if you can figure out how to make it into a workflow, and again, I've giving you the tools for that, go and get yourself a gem and create a personality that goes into there and say, convert this into these kinds of things here and use these kinds of capabilities and keep using it. Remember, you're going to keep repeating because the goal is to keep generating. Do not go in and mod the code because then you'll end up with a mess and stop using one or the other very, very quickly. Look at your indexing and partitioning strategies around this. This can now, you may have a seasoned architect that can do this, but you can now give some good science reasons, fact-based reasons for doing this and say, based on these patterns, what's a suggestion for a specific, strategy around that? You can get the sense there. And you can also, I haven't said in this webinar, but the number one complaint from CEOs worldwide is the size of their cloud bill. Now, there's two things that are problematic. One, the CEO shouldn't be concerned with expenses, which tells you that they've gotten out of control. And two, the thing has gotten away from the CIO, the CTO, the CDO, whoever is responsible for it and doing this. Finding ways of saving money on your cloud bill is a really good objective right at the moment. Again, I've already told you 80% of your data is redundant, obsolete, or trivial. You don't want to put it up there in the cloud and do this, and your data volume should be significantly lower in order to do this. And finally, refactoring your legacy to modern systems. There's a lot of things that can be done. I've done this manually so many times at this point, I can just tell you there is an absolute ton of savings to be able to get this. Here's an example of it. Again, don't try and read it right now, save it, come back to it later on, but you can see it's a pretty straightforward confirmation and it's going to give you its rationale as it's going through it. Kind of useful as far as that. So let's sort of go back and take a look at where we've been. Why are we modeling anything? And the answer is because models allow us to define that essential set of information that's in here. Again, the icon I've been using this entire time, all the model changes can be done within this particular series of constructs here in order to do this. Data modeling then is designed to accomplish the data modeling portion. Now, those of you that don't know my background, when I was a student at one point in time, a professor put in front of us a bunch of papers and told us whether to decide whether to accept them or not. It was for a journal that was going to be called the Journal of Data Requirements. And they were not good, but we ended up studying requirements. And it turns out that the data requirements are the most objective, the most testable, and the most need of stability for large projects. And the larger the projects, the more critical it's going to be. I'm going to go off on a quick tangent here, but the Office of Personnel Management in the U.S. Government has put forth an announcement that says they're going to create one HR system to rule them all. And this HR system is going to incorporate all the requirements for all of the HR, all the federal government requirements in here. And I'm pretty sure they're going to try to accomplish this without doing any data modeling whatsoever. If you can imagine such a thing and such a colossal waste of taxpayers' money, I will tell you why that's not going to work, perhaps in the Q&A part on this. So when should you look for AI help? Well, the more you do with AI, the more it knows about what you're doing. Again, find out what your rules are, of course, on this. The more it can be helpful to you. I have just been so pleased at some of the suggestions, and maybe I'm just stupid, but the AI is thinking of things that I haven't yet thought about, and that's refreshing to me. Uh, from that perspective, then, there are three different types of modeling. And I didn't say it earlier, but now that we're at the end, I can tell you, you really shouldn't model unless you're trying to answer a specific type of question. Most of the time, modeling for modeling's sake sort of left us back in the 1980s and 90s and the aughts in order to do that. But regardless, your first question is, am I conceptually, logically, or physically modeling? Am I thinking about what might be? Am I thinking about what might actually be in progress? Am I trying to understand how it does something? That's the logical definition, how it does something. Or am I physically interested in how it is doing something with respect to the technologies that are? Each of those three are critical pieces. And I say this over and over again, and people come back to me after years and say, thank you for doing this. On each of your models, I'm putting a blank screen up right now, right at the very top of it, the purpose of this model is to, and then put that down. It will help you so much in the long run. I was taught that by Clive Finkelstein many, many years ago, but it is so useful. It has been so helpful in order to pull all of that. So as we get to our Q&A spot around the top of the hour, just got a couple more thoughts to set up for some takeaways and a lot of reference material for on this one because a lot of good people have contributed to this. First of all, here is a conceptual HR model. Now, please don't try and read this right now. Again, you're going to get the pictures of it in order here, but you can see it has some very nice definitions, skill, address. These are things you should expect to see person, person type. Again, a person could be a salesperson type and a manager type, if you recall from one of the earlier examples that's in there. I believe this is PeopleSoft. I'm not swear to it on that. The logical model was slightly different. They said, look, we're just really trying to answer these kinds of information around here. And then the physical model was very, very difficult. Again, impossible to read. So I'm going to blow it up for you and let you walk through it. There's the first piece of it. And you can see, again, with the detail part one of part two of, part three of, and part four of. So now you know what you're looking at when you're looking at this entire model that's out there. Those track very, very well. And I used to have, I still have the electronic file, but no longer the tool to open it, that would actually give the integrated definitions back and forth across all of this. This kind of understanding is what's needed to go before you can add AI successfully in your organization. Because if you don't understand the workflows, and by the way, PeopleSoft does understand workflows at an exceptional detail. Again, I'm, like I said, pretty sure this was PeopleSoft. In order to, gosh, I wonder if that means Oracle's going to sue me now because I'm talking bad about their HR project too. Ah, ha, ha, we'll see. Anyway, moving right along, there are some correct ways to organize data. And You can do it for flexibility, for adaptability, for retrievability, for risk reduction, but you can't do it for all of them simultaneously. And so make sure that whoever's putting these things on you doesn't just say, I need these tables, but I need to know why these tables, because that's going to allow us to implement some of the best practices that we've built up over the years in order to understand how things work. Again, take it a little bit further too. Again, world peas, right? Well, that's probably not going to work as far as what we're trying to get to. We want to keep it focused with the purpose statement of the model, and then that way you can say the reason we are locked in this room is to understand the formal relationship between customer and soda. Probably not on everybody's list of understandings, but I guarantee you there's some companies that have been through many, many concerning meetings with this and probably didn't have the tools to do this. But if that's one way of describing it, it's a very simplistic way. It does give us the ability to walk out the door with an as-is logical and physical model of these relationships that occur out there. By the way, just a quick point of note, does anybody happen to know why Coca-Cola and the other companies are starting to let you mix your own beverages? Because they want your data, right? Absolutely. It's absolutely oh, that's right. We got to get them to pay for it. That's going to be important here as well. What are the characteristics that differ between our hospital beds? We want to walk out the door when we identify the top three characteristics that represent the brand in a logical data model. So there's something about the beds that are going to show up in advertising either to a RFP or to some other type of general awareness campaign looking at this. Again, does it change our perspective to know that they're going to use beds to try and figure out where the patients are? Does anybody know what they actually did? They put it on the wrist. See, that makes it even easier. Hopefully, none of you have that much hospital experience and you don't get that type of understanding on here. Here's another one. Could our systems handle the following business rule tomorrow? Is job sharing permitted? Well, in this instance, an employee has exactly one position, and a position can be filled by zero, one, or many. Congratulations. Our systems can absolutely handle that particular requirement. And we can say that authoritatively because this is a physical as is analysis that we're doing on these things. Again, when you're modeling for it, the sake of modeling for the sake of modeling disappeared a long time ago. What we're trying to find out, though, is that if there is no disagreement on this, then somebody's not paying attention. So we've introduced errors into the model sometimes just to make sure that people will catch things. And once they do and they see that they're rewarded for it, it becomes a game for them. They do enjoy the process of making better what we're going to create for them in order to do this. Incorporate those purpose statements in here as well. It's a problem definition as well as a problem solving activity. And until you've defined the problem well enough, it's impossible to solve it accurately. So again, different modeling challenges do different types of problems, different types of modeling techniques. Data modeling is important, but there's lots of other types of things that can go into that particular process. They should be maintained as a living document for the most part. And again, remember that iterative process, because if we're not having them do it iteratively, it becomes very much problematic. One and done just generally does not work in order to do that. So accomplished iteratively using an approach focuses on one aspect at a time and comes up with just little bits pieces here. I got yelled at by a senior executive and it taught a very good lesson in the process. Like I said, getting yelled at is actually quite useful these days. We were showing a model and it was extremely boring. And she was trying to get it ready so that general officers would understand this. And she said, "Where are my damn battleships?" And by God, she was right. You show them a box or two and tell them that represents things that can float on the water is not going to go over as well as if you add a little bit of clip art to the process and make it more useful to the users. Obviously, the clip art can't help you build your physical as is model, but it will help you sell the project conceptually as you go through things. Again, catch me on the side and I'll tell you about the one conversation that I had in a room with the defense secretary who was uh, asked to learn about this sort of stuff. And again, speaking of learn, there's a lot of really good material. So hopefully this is not your first look at this. We used to start out with something called the Government on Handbook Systems. Now, of course, we've got the DIMBOK, and of course, now we've got the revised version of the DIMBOK. And you can see here that data modeling is one of the various practice areas that we have around this. Again, lots and lots. Like I mentioned, we did do a revised version of this, so make sure you get the our revised area and learn about the 11 practice areas of which data modeling is just one on this. Lots and lots of works that have been cited on this. Sorry, I don't have a good piece for it. Our good friend David Hay has got a fantastic book that will get you to this. Bern Tarlm has retired now, but there's still lots of good material that he has on the web there. I would encourage you to follow up on this. And of course, Gordon Everest, can't forget him at the University of Minnesota on this. Another one, if you don't know Graham Simpson, again, wonderful individual, has actually gone off and done a whole series of books and plays and things like that. But back when he was doing his PhD was about whether or not data modeling is something that is done to do documentation or something to actually solve the problem. And his answer was both, as far as that goes. Again, one more show at the bookstore there. Again, special pricing right at the moment. And we are right at time to come back to Mark. Hi, Mark. Did I slow down
Peter?
enough? Yep.
Well, we had a few people that had trouble keeping up, but luckily we
I'm so
record these
sorry.
sessions, and
Exactly.
yeah, and people can always go back and put it on 0.75 speed if they want.
It's very nice that the
Um,
voice doesn't change. That's the best part. I usually
yeah,
listen to 1.5, right?
the more you speed me up, the more Canadian I sound. We do have some wonderful questions and some micro debates in the Q&A and chat. And so I'll start at the top of the list here
All right.
because I love this question and I feel like this is a debate. So if this questioner is coming to conference, this would be a wonderful uh, 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 in-person discussion to have with a lot of friends. How can AI generate valid naming from complex attribute names without some form of definition? And the debate points were somebody had posted it can't, and then somebody posted, best I could do is take an educated guess. Definitions are needed, even the smallest ones can be helpful. What are your thoughts on this, Peter?
Well, one of the mistakes that I think people make oftentimes around AI is thinking of it as a binary kind of thing. Mark, you and I have had enough conversations about it to know that it's an adjunct to what we do. And
Hmm.
so just as if I was, you can see I'm playing my bass here in this particular little picture there, but I will use a tuner because while my ear is good, it's sometimes not perfect in order to do that. So the question really is talking to the importance of these glossaries that have to be there. And again, it's the first step that you do with any data governance initiatives. It's absolutely required that people have this common understanding of all of these things in order to do this. And so whatever you can get there is generally my answer on that. And that rather than trying to take all of your materials and run them through an AI and have an answer, I would suggest more along the lines of the way Nokia did things, which was that when they used a word that they were unsure of, in English typically is the way it was, they would just simply look around the room and say, "You guys with me?" And sometimes they are, sometimes they aren't, and try to pull all of this together. That way, you're constantly looking at reviewing things and things, but the sort of the batch approach of feeding everything in and coming up with answers is probably not the right type of piece. But it sounds as if there was some complexity behind the question, and so certainly a workflow that would produce the right results every time could be augmented, and that would be the direction I would look at. What do you think?
Yeah, that's so I love your answer and my my pithy takeaway from that, if you were to boil that down into a sentence, if you're using AI for catalog generation or definition generation, your your philosophical principle should be, I don't care if this fails. Maybe it'll help me out, maybe it won't. Maybe it'll save me some time, maybe it won't. It's fine. Like let it try and help you. And I get I'm doing a little bit of work in this area right now, just because I find it fun. And so I threw a couple of different LLMs at a synthetic data set that just had some silly column names in it. And it actually taught me something about PII in the process. So I had like a silly nickname field for like Starbucks nickname or Starbucks order name or whatever, right? And it said, "Is this PII?" And it said, like some organizations think this is PII, some think it's not. And but here's the reality of the situation: is that if this type of field can identify somebody, it should be considered and treated as if it's PII. And I was like, yeah, of course. Like, and I wouldn't have considered that on my own. I do appreciate the complexity of attribute names, especially in enterprise systems. I won't name the system, but I'll name the field name. If you've got a column, if you've got a table called SPB pers, and your fields are SPB pers underscore 01, SPB pers underscore ID, SPB pers underscore name, how is the AI, without any additional context, supposed to generate something meaningful from that? It doesn't make any sense. So your mileage may vary depending on what's going on in the system and in the data. But like these models can profile the data as well and determine some flavor or context around what's in it. Um, but like, yeah, caution as well. Like, don't just turn these tools on and use them. You have to be aware of what's happening when you press the button too.
The nice thing that what you're describing, Mark, is that you can use the customer's words to express the customer's concepts. And
Yeah.
so by feeding something like that into it, it's going to come out with the types. Again, this, you know, 110, 100 from the manufacturing community is a real interesting piece of insight. And I'm having a lot of mileage using it in there because people understand that and get the context. We don't have to resell them on this. So, certainly meeting everybody where they are is our goal for sure. I'm not sure we answered their question about it can't or educated guess, but I'm at least advocating micro uses of it, and you're advocating a slightly modified approach on that.
Yeah. What do you suggest, or what you suggest? Oh my gosh, my apologies to the questioner. How do you map traditional ER modeling for data lakehouses and data lakes? How do you approach that problem? So if you're doing entity relationship modeling for a data lake or a data lakehouse, what's your typical approach?
Writing the question down so I don't forget it, right? Um, the almost always, I don't think I've got a good answer, and maybe you have a better one, but I've been guided by whatever the process my customers are working for. Most of
Yeah.
them have fairly mature approaches. And so some of them, for example, like to start out with just naming all the nouns and things like that and going from there. But I have not had the ability to make one up. And maybe that's probably for the best. How about you?
Like I think it's a it depends situation, right? Like what are we putting into the data lake or the data lake house and what are we going to use it
Starbucks
for?
nicknames.
Yeah. Well, yeah. So, and what does that mean? And is there value in it? I always kind of go back to this and is what I'm doing as a data professional providing value? So is there value in me building this model to have a communication tool? Is there value in me building this model to make the lake house a better product? So always add value, right? That's kind of where I approach those sorts of things. And if if we're doing like an entity relationship model, like how do I approach that? Like when you get into data lakehouse land, I guess that happens a lot more. Like, what are the types of things we want to report? And there's going to be things that pop out of that. So, I mean, it's going to depend. It's going to depend on the project and what you're using the data for, right?
Fair enough. Sorry, we couldn't give you a good answer. Maybe the AI will do us one better.
Yeah. If that's what we should do. We should have an AI agent that tries to answer questions. Then we could
Hey,
giggle
Mark, let
at
me
its
just ask you,
accuracy.
do you have any that you like to aside from the general ones? Do you have any specific chatbots? For example, I'll tell you what mine is. I used to be a MailChimp customer. I like them. Their
Oh yeah.
first level customer service is actually completely 100% chat based and extremely useful. And I find that they've just done a lot of thought. I disagree with them on their pricing models, and that's why we're not customers anymore. But nevertheless, I will certainly give them a shout out for their level one support, being able to do it with a chat bot and really understanding the problem and able to come up with something useful.
So I'm of a couple of different minds of this. I generally like, and people can like throw confetti at me. I'm a bit of a Microsoft fanboy, so I kind of like Copilot. And I can feel the eye rolls through the internet. Um, but I like the simplicity of that and how accessible it is to users. Now you need to exercise some caution, obviously, with turning on these tools. Don't just turn things on without an understanding of what happens when people prompt them. But I'm a fan of Copilot because of that ease of use. Otherwise, though, I'm a fan of building my own model. So, finding an open source version of something, bugging the kid to set me up a VM and train a model on my own. There's a lot of power to that, and there's a lot of power to these small language models too. There's a lot of interesting things out there. I think if you're shoehorned into a single thing and that's your experience, I would encourage you to branch out and see what else is out there, just so you can feel what different is like. Does that make
I
sense, Peter?
100% agree with you. Again, as people in this business, it really is incumbent on us to stay current. And so I try to I've got a podcast that I listen to. It's called The Last Invention, by the way. Really recommend. The first 8 episodes are all about the history of AI, is a really, really articulate history of it. And then just to give you a preview, one of the more recent episodes, they interview Steve Bannon, and he actually has some thoughts that might be very interesting. So leave it at that, though. What's our next question? Quickly get off of politics, right?
Yeah. Actually, something just came up in chat that I love, so I kind of want to ask this question.
Go for it.
With the explosion of types of data, how to approach modeling of multimodal data like tabular data, JSON data, image data, Internet of Things data, and text?
And let's be clear, they are already being modeled in most instances.
Hmm.
Otherwise, they wouldn't have gotten to where they have gotten to. The key is to understand that whatever you're doing, it's been done before. Does any Mark, to see if I can ask, do you know what the original rationale? Let's see if I can remember this. It's a good story. It's like one of the original rationales for something. Oh, I know what it was. It's the original rationale for why television signals were transferred over the internet.
Oh, I was around too. I vaguely
Yes, you were.
remember this.
So it was a pot of coffee at the end of the hallway, and nobody liked to get up to go look at it. So they just made a camera and focused it on the pot of coffee, so you could see whether it was there or whether you yelled for an
Such a
intern to go.
developer thing to do.
Of course, uh, but it is that kind of thing that we're looking at in terms of what can come in. So, if you can make a vision supplemented system that can look at the back of a bunch of trucks in a parking lot and can determine a false alarm of somebody just simply getting in the back of their truck and doing something versus somebody stealing out of it, there's a model for that. And there's value in going and finding out what that model is rather than trying to reinvent it in there. So that would be my guidance.
Yeah, I 100% agree with you. I like to think of how modeling is different when I'm working with different types of databases. So because I'm a big fan of graph databases right now and vector
Mm.
databases and different types of relationship modeling that happens in graph databases, like everybody likes to say, well, I don't need a data model because I'm just gonna huck it into this cluster thing, or I'm just gonna huck it into this vector thing, or I'm gonna have like a circular hash table or something. And there are people who have solved this problem and for reasons. So like hit up the incredible edible internet and see what kinds of things you can find. And like, but still ask yourself that question, like, what is the value in this? Like, am I adding value to this? And in data modeling, and Peter, I'd like your thoughts on this. Um, Really, we build data models so that we can talk about data at a level that people are at. Like, it's a communication tool, right?
Again, to Graham's thesis here. It's really quite a good book, and he's a very interesting person. But yes, the both aspects are critical for what we're doing, and it's unfortunate that we use the same word to describe them both, because it does present a little bit of a barrier to sort of figure out what's happening and what's going on in these areas. But you know, I've worked with really excellent data modelers over the years, and almost always, as soon as we start talking about the problem, they'll pull out a piece of paper and say, "Tell me more about this now," and hone in right on an item of uncertainty or imprecision that can get us to a solution much faster on this.
Somebody asked the $1 million question in Q&A. Can we see a demo where
Yeah,
we can feed the requirements and Gen AI can generate a near to accurate physical model, DDL mapping, and so on?
I didn't do one all the way through. I do have a couple of examples in here that, again, I'll just go back and point out. But try it yourself. I mean, you'd be amazed at how
Mhm.
quickly and easily it can do it. Like I said, it helps to get this persona thing down first. And that was, I guess, maybe a point on the particulars of it. Yes, I agree with you, Mark, in terms of getting out of your seeing what the other half looks like and all the rest of it. It's going to be just like clouds, I believe, that everybody will have everything. And so it's just going to be a matter of what works well within the environments that you're working on that.
100%. And if you're coming to DGIQ and Enterprise Data World in early May, like come and find me in the hallway and I'll whip up an LLM and we can just sit and try to make this work. Like this would be an excellent kind of off the side of our desk kind of experiment.
And be careful because Mark will talk you into doing a lightning talk with him next year.
Exactly. That's 100% true. Mhm. We do have another question here. It seems like the metadata catalog for a large enterprise with thousands of systems becomes too much for humans to grasp. Is it too much for AI at this moment?
I don't know the answer. Perhaps you do. I am running an experiment with a $60 million a year organization to see how far we can actually push that, which is definitely not the same size as Walmart or other organizations of its kind, but it is absolutely a question being investigated, and it's a really good one. If anybody wants to volunteer, I have lots of classes of students that can help out with the process.
There is, I won't name the vendor because we're vendor neutral, but there's a vendor that has a chatbot built into its interface now to basically surf catalogs, surf integrations, surf systems, and it gives you because it's a an LLM chatbot, it's got that natural language processor. The amazingness of how it can distill the complexity of a large organization, and I've tried this at a large multinational organization, is mind-blowing to me. Like how good these tools are is mind-blowing to me. So I don't know what the upper limit is because I haven't run into it. Which maybe that's a shocking statement, Peter.
I don't think so at all. It's the more the real question is going to be, can we figure out a system where it can retain some of what it's understanding, and
Yeah, that's a
that's a
great point.
non-trivial problem. But at least
The
it look. We will get this. Here we go, Mark. You'll appreciate that. We will solve that problem well before the multiple inheritance problem is solved in the object-oriented community.
yeah,
I
that's
knew
a
you'd
great
like that one.
reference. Yeah. Actually, my kid's taking programming language, and it's like, why is it like this? That's exactly what she was talking about, and I'm like, yeah. But I love the call out to agentic memory as well. Like, will the bots remember conversation to conversation, and what does it mean for them to remember in the first place? And, when you're dealing with that level of complexity, it needs to have some flavor of agentic memory. Um, uh, and yeah, that's if you haven't
Again, I
read about
was
that yet, I mean, it's super interesting.
absolutely, and we're going to need some experiments, and hopefully, when you guys get it, you'll come to a conference and tell us about it. That's how we learn. I got the best job in the world, Mark. I get to go to lots of conferences and listen to lots of really smart people tell me things. So
Oh,
it's fabulous. But here's where we started off today. I was doing something completely different. I was creating a chart of a little piece that I could walk my students through. Believe it or not, it's so bad in the classroom these days that you actually have to put the answer up on the screen and then they try to read and figure out which is the correct answer in terms of how all that works. Very, very sad on this. But it noticed I was doing something completely different and decided to make a side point. Hey, this might be of interest to you. And goodness, it was quite insightful.
we've got one questioner who has a great modeling question here. How do you design a metadata schema for unstructured data like customers' emails or images? What fields are essential versus optional? It doesn't feel, this is my words a little bit, that we can follow conventional entity relationship modeling.
Well, once again, first of all, this has been done before. I have never done it, so I can't point you directly to sources, but I guarantee you that somebody has analyzed the data that comes in off of images, the metadata that comes in off of various audio formats and things like that, and brought that information in. And that once you have that type of a thing as a starting place, you combine that with the business requirements and you will get to where you need to be on this. But if you sit down by yourself and start to do it one at a time, it's going to take too long and probably not deliver that business value that Mark is always harping on about, right? Why do we need business
Value,
value?
value, value.
Exactly, exactly. Good question.
It is. Um, what is, I think my upvoted question list is becoming limited. Um, what does your LLM need to have to do this work? What are the memory requirements or agents that do something? I think this is a deeper technical question.
Yes, and it's a really good question. Ironically, my task after I finish work on Thursday night, a week from now, is to go to my local county courthouse and protest the incoming data centers that are coming into our rural community here. Remember, I'm connected to the internet by a twisted pair of copper wire, right? So it doesn't do much for me. So, from that perspective, it's kind of really sad on this. But there's two things that are happening. First of all, just like what is Uber's number one question, number one priority that they have, it is driverless Ubers, right? So as fast as they want to get rid of the one thing that makes them kind of unique. I say Uber, it's the same thing with Lyft and all the rest of them. So what do you think the data centers are doing? They are trying to figure out ways of doing this without doing these big honking data centers. And it's an industry, it's a whole series of things. We found evidence in our community that they had actually reached out to the industry like 7 years before trying to put this in. And you're thinking, how can they put that much effort? There must be a tremendous amount of money that they're making off of all these things. But at the same time, the Apple M5 chip is big enough to contain an LLM on itself. And so the idea of putting together two Super Max chips, I think they're called, or M5 Max chips and running things local is going to become increasingly more uh, advantageous, which again gives you as a customer the ability to substitute your own uh, information on it. I use what is it? I'm going to say Onyx, but that's not right. Hang on, I'm going to take a quick look. Obsidian. There we go. I didn't even have to look at that.
Yeah.
And that's a good one to get up and running on that. There's several that run on device and that you can use. And you don't have to go out and buy a lot of NVIDIA hardware in order to get it to run.
Mhm. Yeah, this is the ultimate it depends question, right?
Hmm.
Like, like it depends on what you're trying to get it to do. It depends on the training data. It depends on the instructions. It depends on the prompt. It depends on the inputs. Like there's a lot of stuff here that's going to change how much compute it's going to consume.
And
So
your data model is going to specify those requirements. And the data model, that if they're trying to do AI without asking you to participate from a data modeling perspective, I don't predict success for their AI initiative.
yeah, 100%. Yeah, that's exactly right. Yeah. Da, da, da. I think we probably have
But
time
gosh,
for
we ought to
one
tell
more
another joke or
question.
something to entertain everybody.
It's
Thanks, you
we've got
guys.
so many questions. I'm having trouble filtering through them here. Um, oh my gosh. Okay, I'm just gonna pull the trigger on this one because I like the words that are in it. For the last several years, everyone has been pushing the term modern IT stack. I've heard it all the time too, and shove all your data and applications into the cloud, and because data storage is cheap. I never brought into this approach because it looked like a fool's folly. I love this guy. I took a lot of grief from my peers for this. However, you made a comment earlier about the escalating cost of cloud. This doesn't surprise me in the least. The chicken's coming home to roost. It seems like folks will need to spend time to drop out of the rot. What are your thoughts?
Absolutely. Well, thank you for picking up on that little dropped gem that I gave in there. Yes, absolutely. Let's just think about something, a scenario here. And Mark, maybe you can help out with this one too. In the old days of teaching the computer how to figure out how old I was, you would take the year I was born, 1959, and store it, and then subtract it from the current year, 2026, discovering I'm 6'7". And so, in that context, that makes perfectly good sense. But what if you were doing that for literally millions of customers on a periodic basis, like several times a day in some instances? Um,
Mhm.
you're paying too much to the cloud vendors to do that. That is not a good way to design that kind of data flow. So you can examine things that are associated with your cloud implementation. Another thing that people are really disappointed to discover about cloud is that it is not a backup. If you want to back up your cloud stuff, that's extra. And so, you got to make it happen. It's not just going to happen by itself. Like I said, those data requirements are the most objective, the most testable, the most structurally sound that you need to have going forward on that. What about you? What do you think?
Well, I like to keep saying that bell-bottom jeans are coming back in style,
Woo!
um, because like everybody was pushing into the cloud, and it was kind of, and so this was in the late noughties, early tens, right? And people were like cloud first, and then the reality of the cost of compute started to hit in cloud, and we're like, oh, we have to be careful, but whatever, it's still fine. But now people are getting hit with compute costs again because they're training AI models on what they have in the cloud, and so people's cloud bills are going way up because AI models are training their faces off on something that's not on premise. So I've actually seen a couple organizations move training data on premise,
Mhm.
and keeping it internal and not exposing it externally, so that they can train their LLM or their small language model. Um, uh, uh, just off of on-premise data and then not have to pay a six-figure cloud bill by surprise, which I've seen. Like I've seen people who've had to do that. Like, oh my gosh, your cloud bill is like over 100,000 this month. Yeah, we turned this on and just let the spigot go and it was bad.
And on that happy note, again, if you model your data, you're going to understand its characteristics a whole lot better. And whether that
Uh-huh.
additional modeling effort is going to help you out or whether it's going to add incremental value or not to this. And that's as Mark said several times, if we're not focused on the business value here, one might ask the question, what are we doing it for?
Yeah, exactly. Well, with that, I'm afraid, audience and chat, thank you
Thank you
so
all
much
so
for all
much.
the
Yeah.
questions. But that's all we have time for today. Great presentation, Peter. Wonderful topic. Thank you, everybody, for being so engaged and popping into our webinar. Uh, have a wonderful rest of the day.